Hi guys, 4Tutor here. When I was recording my 157590 triangle derivation video, I forgot to explain a little minor detail. It's how to simplify a complicated square root inside of a square root. This video will hopefully teach you how to solve it. There are many different ways to solve this, but this is the one I find the most efficient and the easiest to remember. If you recall from the video, you should know that there was some term called square root of 8 plus 4. My god, my computer. Um, plus 4 square root of 3. This is not a very easy number to work with. And hold up, I'm just going to put this all in parentheses so it just looks better. This is not a very easy number to work with. So in this video, I hope to teach you how you can change this into a much more, let's just say, workable square root. In the video, I changed this magically into a root 2 plus root 6. Well, how do you do it, Aarit? Well, it looks like magic, but it's really, I'm not going to say it's simple, but it's easy to understand. However, I'll walk you through this process, which is the easiest for me. So what I did first of all is I set it up as a system of equations because I know that it will be in the term a plus b root 3. However, if this was a root 2, then you could say this is root 2. So basically, this number has to always match this number. I'm going to keep it at square root 3 because I want to, equals, and then you set it equal to the square root of 8 plus 4 square root of 3. There, now you have this equation. Now, normally to get rid of a square root, you would square both sides. However, there is still a square root, but still, don't worry. Just square both sides for now. When you square both sides, you'll get the equation a squared plus 2ab root 3 plus 3b squared. Then that will equal 8 plus 4, 8 plus 4 root 3. And yes, I did go digital this time. I'm not bringing up anything. It's a nightmare to fill it on paper. So now you have this little equation. I think you can begin to see a system forming. Since the 2ab root 3 term is the only term with a radical in it, you can set it equal to this. Because there's no other term with radicals, so the 2ab root 3 must equal. However, to simplify things, you could just write that 2ab is equal to 4 by dividing both sides by square root 3. And then that leaves the other part of the equation, which is a squared plus 3b squared equals 8. Now, you have a system of equations. However, let's just say it's not the easiest systems of equations to solve because it does involve some, let's just say, complicated things like rational systems. However, I'm going to try my best to solve it for you. So, since the first equation doesn't have any square terms, you could just solve it for either a or b. I'm going to solve it for a because it's much simpler. So when you solve it for a, you get a equals to 2 over b. Now, all you have to do is just substitute it for a squared. So you would basically just do 2 over b squared plus 3b squared equals 8. So, and that the 2 divided by b squared is equal to 4 divided by b squared. Yeah, I accidentally put an equal sign here. Let me fix that quickly. Plus, and then you get plus 3b squared equals 8. Now the next thing you would do, instead of, look, there's a rational equation here. So generally with rational equations, you would want to use least common denominator. However, since it's just one term that's rational, you can just multiply it by b squared. You have to multiply everything by b squared. So now once you multiply everything by b squared, you would get the equation 4 plus 3b to the fourth power, because remember you're multiplying this by b squared as well, equals 8b squared. Now you have a much more workable equation. It's not a quadratic, but at least it's a quartic polynomial, a quartic trinomial, which means that you can factor it just like a quadratic. However, to make it more simpler, I'm going to move 8b squared to the other side and order the terms. So the actual equation would be 3b to the fourth power minus 8b squared plus 4 equals 0. There's now, generally I would directly factor this, but I'm not going to do it this time because this doesn't look too factorable. So what I would do is I'm actually going to introduce a new variable called c and set it equal to b squared. And now essentially just substitute c for all instances of b you find. So now you have the equation 3c squared minus 8c plus 4 equals 0. Now this is a lot more workable. And you can theoretically factor this. However, it is like, yeah, I'm not gonna go over how to factor this equation. All right. So once you solve, I'm just gonna skip over the actual solving of this equation. But once you solve this equation, you should get c is equal to 2, and yeah, c is equal to 2. The other solution we're not going to use because it actually no, it's negative 2 negative 2 thirds. So now when you plug these in, you'll find out that this negative 2 thirds solution is extraneous and will form a negative length. So now we just have 2. So now all you have to do is just solve for b. So remember, 2 is equal to b squared. So b is equal to plus minus, I'm just going to write it like that, root 2. Remember, we want it to be positive here because this is the side length we're talking about. So it's just going to be b is equal to root 2. Perfect. Now we have b, so now we can just solve for a. So a is equal to 2 divided by square root of 2, which is the equation that we substituted originally. Now all you have to do is literally just solve for a, which is easy. Because you need to rationalize the denominator. When you rationalize the denominator 2 divided by square root 2, you multiply the fraction by square root of 2 times, and then square root 2 divided by square root 2. So now you have the equation 2. So now you have the expression 2 root 2 divided by 2. You can simplify this further and get rid of the 2 in the term 2 root 2. So now you're left with just root 2. So now you know what a is, because, well, we just rationalized the denominator. So now that you know a and b, you can plug them back in the original equation, where I said a plus b is equal to square root of 3. So now you have the equation, which is root 2, which is a, plus root 2 times root 3. I would compress this. I'm not going to leave it in this form. So to compress it, you could just multiply these two radicals together, square root 2 and square root 3, which would compress to become square root of 6. Roots. My god. So that the final answer would be root 2 plus root 6. So to walk you through this process without using just one equation, what I first did was I set it equal to this expression, a plus b square root 3, or whatever root this is, and then I squared both sides to get rid of this first square root. And then after that, I solved equations by looking at the terms here. Remember that 2ab is equal to 4 because of the radical here. And a squared plus 3b squared is equal to a because those are the two remaining parts of the equation. And then what I did was solve this equation. It is a bit tricky to solve this equation unless you have knowledge of like rational expressions. Um, yeah, I'm just gonna keep it plus minus. It's tricky to solve it as unless you know rational equations and how to solve them. However, it's not as tricky as other rational equations because there's only one term, so you could just multiply it all by b squared, which is the least common denominator. And then when you solve the system, and then you just get the two answers, and then you plug them back into the original equation to compress it further. I hope this video was informative. And remember, this is actually used in a lot of derivations for triangles. Like, for example, the golden ratio triangle, which is 1872 and 90. It also uses this, I think. So, I guess thank you for watching. And yeah, don't forget to subscribe to the YouTube channel. I appreciate the support. And or email us at 4tutortutoring@gmail.com for actual classes. Because we teach these things really well. Well, I guess that's it for today. Goodbye, and I hope you found this lesson informative.